Yeah, hi everyone. It's really good to be here. Really enjoy being here in Tallinn, really enjoying the company and also like the speeches and the hosting and everything. It's been super nice. As Ilya said, I'm Fotis. I work for Wolt as the Frontend Competence Lead, and I'm here to talk to you about some browser bugs, basically. We're going to arbitrate a little bit about what they are, what's up with that, and we see where we end up. I don't need to tell you more about myself. I think we can talk about it later if you want. But this is not working. Huh, fun. Okay, well, I'm going to click through this. So I think one of the best parts about working on the web is that it is always changing. I think it's super cool that it's been around for 30 years. There's many things being added, many things being changing, becoming more ergonomic and so on. Rarely things being removed, actually, and in principle, you could visit a website from 30 years ago and ideally or hopefully it would still work. That said, one of the most frustrating parts about the web is indeed that it is always changing. It's really cool that we're getting new capabilities and ways of doing things. We can be more ambitious with the things that we build, but then there is a lot of stuff to keep up with. Ooh, no, shouldn't have done that. Sorry about that. I hope you're not photosensitive. All right. So what are we going to talk about today, right? Keeping this in mind, we're going to talk a little bit about browser and evolution and features. We're going to try to arbitrate what's a browser bug and what is not. It's a little bit of a futile attempt, but we're going to attempt to do that just for the sake of fun, I think. We're going to look at tools for adapting to this changing browser landscape, and perhaps some tools to remove those previous tools when the landscape no longer applies. I'm sure this will make sense by the end. And hopefully we'll have some time for a Q&A and a wrap-up. And as always, I have a disclaimer that you might have seen all of these topics before, you might have seen some of these topics before, or exactly none of these topics before. And I think all of that is fine. We're going to step through many things today. This is not a comprehensive how-to guide. I'm here to pick your curiosity a little bit. And I just hope that we get to chat about it afterwards, because that's kind of more of what I enjoy doing. So yeah, what's up with browser evolution and features? I went to Wikipedia the other day, or a few months ago. This is the browser lineages. Look at it, it's magnificent. And this orange thing on the right-hand side is where we are today, basically. So there's many lines of browsers. I'm sure WebKit and Blink and Netscape is probably somewhere there, and Firefox and so on. And there are still pretty frequent releases over there on the right-hand side. And in fact, there's a new version of a major browser every month, more or less. I have an asterisk there. I'm going to be a bit of a weasel in this presentation. What a major browser means is very different depending on what part of the world you're talking about. I'm going to be talking about Firefox, Chrome, and Safari, but there are other browsers out there that are very popular in other regions. But yeah, where I work at Wolt, these still apply. So yeah, let's look at them a little bit. Firefox has this website. It's called whattrainisitnow.com. It's not about trains, but it's actually about Firefox releases. They tell you basically when they come out, when the different betas and developer previews are. Basically every 6 months is when Firefox releases. Chrome does the same thing. Actually, this has been updated since, but it doesn't matter. That tells you what is the current stable and canary and development previews. Basically, they tend to cut the next version a few weeks in advance so that developers, in theory, have time to test in advance. Well, Safari doesn't really do release schedules. They do release, notes, basically. They say, we released a new version. This mostly happens because they are tied to operating system releases, though I will say that this has gotten much more frequent in recent years. And to their credit, the release notes are really good. So I'm not that mad. But yeah, it's pretty annoying sometimes when you don't know when the next version of Safari that has a fix you're really looking for comes out. You can kind of divine when the next release is going to come out if you just look through all of the technical previews. And if you see that there's too many technical previews happening, there's probably a release happening. But don't take that as literal advice for when to figure out when Safari is going to make a release. But okay, those are the kind of release cadence we're talking about. What about features? What's a browser feature? Browsers are very complex. I'm not going to cover all of it here, but there are HTML features. For example, a new element, like the dialog element, or a new attribute, like the inert attribute. You might get CSS features. So for example, there's the has, which is kind of allows you to do relational selections like parent selectors, but also some other more cool stuff. There's a relative color syntax that allows you to define colors in relation to other colors. For example, if you want to darken them or lighten them. And JavaScript has a ton of stuff, basically. You might have something like a syntax feature, so optional chaining, this question mark and dot that allows you to access properties in case they are undefined safely or nullable. and iterator helpers that allows you to work with arrays in ways that are more fun and interesting, and that Python and other languages have had for a while. And there's also web APIs. For example, fets. You can use fets to make a request in a browser natively. And if we were to look at it a bit more abstractly, what are these categories of features? Again, you might have elements and attributes. You might have selectors or attributes in CSS. JavaScript might have syntax and language features or some core APIs, for example, something to do with datetime. And then there are web APIs that relate to all of that allow you to do interesting things with HTML and CSS and access them from JavaScript and so on. More and more things, we're not going to cover them today. So how do we keep up with these features? First of all, I would say that MDN, the Mozilla Dev Network, they're still pretty good at giving you a nice summary of what an element does, what the attributes do. And crucially, to some of the explorations we're going to do soon, they also link you to the specifications. So if you're really curious and want to arbitrate if there is a bug or not in how something works, they give you the links to that. So that's great. Another thing you might have seen is this website called Can I Use? Basically, they try to address the problem of, can I use these features for where I know my users are at? For example, if you want to use optional chaining, it's been in most major browsers for the past 5 years or 4 years or something like that. It's already 2025. But you can go and check there and it will tell you. And the way they do this, they have an internal database of all of the browsers and the features that they support. And it's, there's volunteers maintaining that. And there's a lot of work behind the scenes to make this like table work. And finally, or well, near to finally, there's a site called Web Platform Tests, also known as WPT, not FYI. FYI is like the friendly view of it. The actual view of it is way more brutalist looking, so I chose to show you this one. They have tests, like standard tests, that all major vendors contribute to. The specifications, usually when they write new things, they try to write platform tests for it. And basically you can go in there and see, let's say, from the tests that are defined about accessibility, how are the different browsers doing? For the test defined for the dialog element, how are the browsers doing, and so on. One little corner of this test that I'm very proud of is this little red corner there that shows that Safari is not doing something. We had to work a lot, actually, with my team we wrote this test and had to prove that there was a bug in the specification. I will tell you about this in a moment. Something to do with the content security policy. And kind of staying on this like friendly, developer facing, allowing you to check the progress topics. There's a project called Interop where major browsers get together every year. They gather feedback from developers and they say, what should we focus on for this year? What do you want to become more interoperable so you can use it reliably? And there's tons of stuff that has come out of this already. For example, the inert attribute, the focus visible selector, actually many things relating to accessibility have come through a lot of this feedback. And there's many new things coming out this year. I'm not going to go through them today, but we can talk about them later. So that's kind of features, but I think I promised you something about bugs. So what the heck is a bug? And I will say in general, a phrasing like, it's a browser bug is a very common saying in front-end development. And it can mean many different things, but I think at its core, right, it's like a frustration that you're trying to get something done and the browser doesn't provide it, or it does it in a way that annoys you, that doesn't match kind of your mental model. So broadly speaking, let's keep this kind of like frustration in mind. But okay, if we really want to arbitrate what is a browser bug, can we do it? Maybe, mostly for fun. So let's try to do it. So I will say in kind of order of not a bug to a bug, I would say that missing a syntax is probably not a bug. They haven't implemented yet. Missing a programmatic API, probably closer to a bug. I'll show you examples for all of this in a moment, so don't worry. Then there's something I call quirks, which is not quite a bug, but it's browsers acting in somewhat surprising ways, usually due to historical baggage, and very often due to a lack of specification. And then it's something I'll call bugs, like clearly something that's not to spec and is misbehaving. Let's look at some examples of these. Missing syntax. For example, not supporting optional chaining in JavaScript. It's missing the syntax, but it's not a bug. They have not implemented it yet. Something like not supporting CSS nesting or the has relation selector. Again, probably not a bug. They have not implemented it yet. Similar with not supporting a dialog or some attribute. That's also fine. We're going to talk about how to work around these, missing parts later. What about programmatic APIs? I mostly categorize them a bit higher because they tend to be more frustrating. For example, you might be missing some specific observer API, like resize observer came out, again, like 5 years ago, but it allows you to check when an element resizes. Pretty frustrating, probably still not a bug. Missing a specific method on an element, I think that's more annoying than just missing the element altogether, because then you have to do more advanced checks to see if it is supported. But in general, it gets a little bit more complicated about what's a programmatic API and what is syntax. For example, CSS and HTML are declarative, so there are parts that are more programmatic than others. But quirks, okay, now we're more in the realm of bugs, I would say. So I'll read you some of my favorites, okay? Safari has this quirk where if you have like an input element that's undersized, so if it's smaller than 16 pixels and you tap on it, Safari on iOS is just gonna zoom in on it. And I think that's fine. At the end of the day, the browsers are like user agents. They're supposed to act on behalf of the user and do what's in their interest. And iOS, or Safari on iOS, which is every browser on iOS, has made the conscious decision to zoom in on what they consider to be undersized elements. Annoying, yes, but probably still in the realm of what the browser can do. Other quirks, Chrome before version 85. So you have different ways to do layout on the web. You can go left to right to left, top to bottom, bottom to top, and so on. If you were in right to left writing mode, for example, if you had a text in Arabic, and you were to ask Chrome, hey, what's the left position of this element? It would give you a value between 0 and 100. If you were to ask Safari and Firefox, they would give you a negative value. Pretty annoying if you want to write any code that relies on these behaviors, basically. Again, this was really not a bug because there was no specification for it. So, of course, the browsers disagreed, and that's also very nice to have multiple browsers. So, if you work in a place and you're convincing yourself to only support, let's say, Chrome or something, I would highly recommend you try to support all 3 major browsers at least, because it's quite nice when you need to go to a browser and say, look, the other 2 are doing it this way. Can you talk to each other and figure out what's up? So yeah, this was borderline a bug. And indeed, I would say that after they agreed that, yeah, it should be negative, let's say, this was not up to the spec, and it was indeed a bug. Chrome aligned eventually with what Safari and Firefox were doing. And now we usually don't have to think about this because Chrome below 85 doesn't really have much usage at all left. There's other things that not going to go into too many details, except one. There's a selector called Focus Visible, which actually really relates to Stepan's talk, where the browser will use some heuristics, some ideas, some hints, some shortcuts, let's say, for when to show a focus outline on an element. By the definition of a heuristic is you use a shortcut. So sometimes the browser can guess wrong, basically, and it might decide that because you used the mouse once and now you're using the keyboard, it's not going to show the focus tiles. Chrome and Safari do this a little bit more than Firefox, though I will say nowadays all of them get it quite right. However, if you know C++, I know we're in TallinnJS here, and it's slim chance. If you know C++, there is a link to a Chrome bug that I will bake you a cake? What am I promising? A cake, if you fix it, because it's been standing there for years. There's one API missing that would really help accessibility for many people. And there's more, so those were quirks, let's say, but what about bugs? There's the internationalization API in the browsers called Intel, and that API has a method called supported locales off. Basically, you go to the browser and you say, do you support this locale? Like if I tell you to format a string, will you be able to do it? And the browser will say, sure thing. So if you were to go to Chrome 75 and tell it, hey, do you know how to format months in Azerbaijani? It would say, sure thing, buddy. And then you say, cool, tell me what October is. And it would tell you M10. I don't know about you, but I don't think M10 is October in Azerbaijani. I think it's October or something similar. So that was clearly a bug. Like it was telling you that it was supporting Azerbaijani, but it was not. The 2 APIs were not talking to each other. Chromium, around version 117, had quite a lot of changes in their SVG pipeline, which led to some pretty fantastic flickering of SVGs. For example, we have a Wolt logo animation on the Wolt.com website. It's the main website I work with. And that was just flickering in and out, which was very nice and festive, but it's not nice if you're trying to, show a static logo. And that got fixed. And then a few months later, SVGs were getting really wonky if they were using filters. And I've put a Christmas tree there because we really engage with the browser vendors, at least like on the teams I work with for our frontends. And we do file these bugs pretty actively. And it tends to be that when Chrome does releases, especially around the holidays, they do a cutoff and they say, okay, this version is ready to be shipped after Christmas. So there was a nice bot that said, hey, this version is ready to be released after Christmas. Why should we make changes to it over Christmas? And then somebody from Chrome had to say, well, it's breaking websites like Wolt.com, so I have a little Christmas tree to remember it by. So all these things happen. And the thing I mentioned to you about content security policy, we don't have to talk about this, but there is like a specific combination of directives you can give it that will lead to Safari just discarding all of your scripts. So it's kind of not doing what is intended. And that one, for example, there was a bug in the specification. So that was pretty demonstrably a bug, but a lot of people had to sit down and figure out what exactly is going wrong, because Safari was implementing things according to the specification, but the specification was wrong. That also happens. There's some other fun things we can talk about later. Chrome introduced a new JIT optimization pass that was breaking most websites with styled components. So there was a period of a couple of days that websites were looking a bit funny. In any case, I jest about this, but actually I do take it quite seriously, and I do think at heart that when we have these frustrations, like browsers are very complicated pieces of software, yes, but it is software, it can be fixed, and there are specifications and tests and ways to do it. On our end, on Wolt.com, what we do is we have this nice directory where we list all of the bugs that we know of and that we have filed with browser vendors, such that when they're fixed, we can stop working around them. And there's links to all the bug trackers you can look at later if you want. So how do we cope with all of this? There's different ways. I'll present to you some. In general, I would say there's like three main tools of the trade here. There's code transforms, there's polyfills, and there is manual methods like feature detection or user agent sniffing. Let's look at them. Code transforms, you might have seen them already. Basically, the idea is that you write the code that you want to write, and you ship code to the browser that it understands. They became really popular around a decade ago when JavaScript was having this renaissance of new features and specifications and so on, and people really wanted to use the latest and greatest like classes or arrow functions. And so Babel and other things came to the scene, and basically they do this thing. You write the code you want, and they automatically transform it. TypeScript is also a transpiler, basically, SWC, and so on. And there are equivalents also for CSS. So PostCSS does the same job for CSS. And there's this like set of tooling called, what's it called? I don't remember. I'm sure I will remember it later. CSS tools or something like that. They have a really nice set of plugins for PostCSS to basically make it the equivalent of Babel, but for CSS. And what's really cool nowadays is that standards bodies, like the TC39, the body that specifies JavaScript or ECMAScript if you want, they use code transforms as ways to prototype new syntax, because it's much easier to fix a Babel plugin than to unzip something in a browser. I mean, it's almost impossible to unzip something from a browser once it has gone out to users, because you cannot break the web. So that's cool. To show you some very convoluted or very contrived examples, on the left-hand side, I'm writing code with using consts and optional chaining and let of iteration. On the left-hand side, I'm telling Babel to target browsers from a decade ago, and it does that. The code is definitely much larger than what I wrote, but it can do that. Same thing with CSS. You can write code on the left-hand side, like using the full-screen pseudo-selector and using some specific like color syntax that is more contemporary, and then PostCSS will know to do that automatically. Now, moving a bit more to semi-automatic, semi-manual ways, you have polyfills. So for example, if there is a piece of functionality that is missing, like a JavaScript API usually, you can provide a user space implementation for it. For example, if there are certain array methods missing, you can implement them by yourself and then swap them when there is support for this, and so on. I will say that manual polyfills have kind of fallen out of favor nowadays. They're a real pain, and they have some real performance impacts, because you're trying to implement something that the browser does in C++, and you're doing it in JavaScript with less efficient listeners. I'm not going to go too much detail about polyfills, but we can talk about later. The secret sauce for many of these automatic transforms is this tool called Browsers List. Basically, it's uses a very complicated database, similar to the one that Kana uses, actually the same, kind of. where basically you can write a query and you can say, hey, I want to support users with, or browsers with more than 5% browser users usage, let's say, in a given region, let's say in Finland or in Estonia. And it will say, sure enough, you have to support Chrome 123, Chrome blah, 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 and so on. And the cool thing is that once you can correlate this support target that your app has to what browsers that maps into, you can tell your tools to automatically transform things for you. So if Babel knows that you're targeting, let's say, the defaults are very good, by the way, and even if you don't explicitly use browsers list, it's very likely that you do, because the tools that we use tend to include browsers list by default. So it allows you to, again, combine the code that you want to write with the segment of users that you want to support and automatically get the code for the browser. There are more manual techniques, feature detection and progressive enhancement being two of them. I think CSS in general uses this quite a lot. For example, can I use an attribute or like a selector and just fall back to some other selector that is maybe less efficient if it's not supported? And in CSS you can just do it, because if CSS does not recognize a certain selector, it will just fall back to whatever was there before. And feature detection is a bit of a more manual version of that, where you just try to see, does the environment support this method or not? I'll show you examples in a moment. And that particular technique is quite useful if you're working around bugs. But they can both get pretty complicated. Let's look at some examples. In CSS, you have supports blocks and fallbacks, as I said. In JavaScript, you have property checks. I'll show you about that in a moment. Again, HTML, you would mostly do progressive enhancement, but you can also do a lot of feature detection. If you have access to an HTML element, you can see what methods it supports. And for web APIs, you would do all of those. More concretely, here's another contrived example for CSS. At the top, I am using two color declarations, one in regular RGB, and the other one is in OK LCH. That's a specific color space. We don't have to talk about it, but it's pretty cool, and it's supported in many browsers, but not all of them. If the web browser doesn't know what to do with OK LCH, it's just going to use the RGB equivalent. And you might write this manually, or you might have some tool do this transformation for you. So you can just write it in the color space that you want and transform it automatically. CSS does other cool things. You can use media queries. I mean, that's a way of feature detecting something about the user's environment. And you can use supports or support utterals. For example, you can ask CSS, hey, do you know what to do with focus visible? And if it knows what to do with that, you might do some resets and so on. I mentioned some in checks, some property checks earlier. There is a method called check visibility that's in actually most browsers and Safari after 16.4 that is massively useful if you're doing manual focus management, actually. Because if you try to focus an element that is invisible, browsers will usually refuse to focus it. So this helps you check if an element is visible in advance, and if it's not visible, you can move on to some other element. But because it's not supported everywhere, you have to do some small check. And ideally, you would cast these checks like we're doing here, because they can get pretty expensive if you're doing them, let's say, on every interaction. And this can get really out of hand, as I said. Like, here's how you might check if a specific property of a method is supported. There's no way to do that directly in JavaScript. What you have to do is you can set a little trap for the browser. So here I'm using a getter, and I'm saying, hey, is the browser trying to access this property? If it's trying to access this property, it probably knows what to do with it. So I'm just going to say that it supports it. It's a pretty niche scenario, but sometimes you have to do it. This actually relates to the bug I was telling you earlier, that there is a property in the focus method called focus visible that will prompt focus visible styles. But because not every browser supports it, you have to feature check for it. And it gets even more complicated if you really want to polyfill this. So here we are touching some manual listeners. You don't have to look at all the details. We basically do this manually instead. And I have a little ghost there. And this is kind of the last thing I'm going to leave you on. Because this kind of code is great. It means that when the browser supports what we want, we only do the thing at the top, which is very nice and small and fast. And if the browser doesn't support it, it will do the other thing. But because we're detecting this manually, this code is going to stay in our code base forever. It's literally going to haunt our code base. And I really don't like code that stays in a code base forever, because it makes the code base less inviting. Like, I know that in all supported browsers, only the top thing happens. But let's say a few years from now, when the bottom code is obsolete, it looks scary. Why would you touch it? Why would you remove it? And if you're not feature detecting, it might actually be quite expensive to do workarounds. Finally, you have user agent sniffing. Basically, you try to directly check what browser am I running on. And you really have to do that in only a few scenarios. First of all, if you're in a server, because you probably can't feature detect something on the client, though there are some techniques. Or if you're working around some very specific bugs, like let's say Chrome 117 makes your logo disappear. Inevitably, you have to know if you're in Chrome 117 to show a different logo or show some text or do something. So it's pretty hard to do. There are some standard-ish ecosystem libraries that will help you do that, but generally not very recommended. For example, that content security policy bug in Safari, you kind of have to check if you're in Safari or if you're serving a Safari client that has that bug, and you just do user agent string parsing. And again, this is going to haunt the code base forever, and worse, because it's not automatic, you have to remember to update this when Safari fixes said bug, which is pretty frustrating, personally speaking. So we looked at some automated and manual methods. The automated methods, they're very nice. You can do them automatically in most cases, informed by pretty standard databases about browser support nowadays. They're relatively unified, and best of all, for me, they will stop applying if you're no longer needing them. The manual methods, on the other hand, they're very powerful. You can do some serious acrobatics if you want, especially if you have some very honest bugs to work around. They tend to be pretty language-specific techniques, though, so you kind of need to know what you're doing, and you also need to bring your team on board to know what's happening in the code base and how to maintain it. And they can be expensive. And worst of all, for me personally, is that they will stay in the code base forever. Our code base is pretty old, by the way. It's like a decade old, so some of this stuff really adds up over the years. So that's the last thing I want to talk to you about is how would you stop working around these, specifically manual workarounds, because we can do it for the automatic methods, right? We have the technology. And I have this theory that code is written by people in real time, but unfortunately for you, or for me especially, time passes and the context changes a lot. And I think the workarounds will stay in the code base, and they will, in the worst case, make the code base slower. In the best case, they will make the code base less inviting. So I was thinking, can we have a way to capture this time in context a little bit to say, okay, this was written in this browser context, does this still apply? Do we have to still do these manual workarounds? And then I was thinking, we already have something that yells at us when the code is not doing the thing we want it to do, or it's not written in the way we want it to be, and that's just called linting. We have linting like ESLint and stylint, for example, that they enforce automatic rules about our code base. So that's what we've been working on a lot on our team. It's called BrowserBug. It's open source under Volt/BrowserBug. You basically combine code comments and the linter and the aforementioned database that knows about browser support in order to yell at you when you no longer need to do workarounds. Very concrete example, and I will stop talking because I know I'm at my time limit. There's a bug here that we have that says, hey, for browser bug ads specifically, Chrome fixed the SVG bug, but only Chrome did. So Chromium-based browsers like Edge and Arc didn't get that fix because it was done with a server-side flag. So actually, the browser support was even more cursed, is that specifically for Edge 117, we had to work around this. So you just add a comment called browser bug. I hope you know by now that I don't consider everything to be a bug, but it's really nice clickbait for people reading through the code base to see browser bug and know that something funky is happening. Then you give the name of the browser and the version, and you can also put a link if you have a reproduction repository like we do. And when time moves on, the linter is automatically going to yell at you and say, hey, this is outdated. You're working around something that you no longer need to. You have my blessing. Go ahead and delete it. Or you have to delete it. Otherwise, CI won't work. And similar things can happen if you have more complicated user agent detection. And again, it's pretty good. It can make your code base a bit faster. So anyway, this combines a little bit of the code comments, database about browsers, and regular linting setup. I think many code bases, or maybe most code bases, have some kind of linter setup nowadays. So it allows us to hook into existing infrastructure, which I think is really good. And there's more details you can look at Volt app. There's plugins for ESLint and stylint that are pretty standard nowadays. So just to wrap up, we looked at different kinds of browser features. We looked at different kinds of bugs, and we tried to categorize them from, maybe it's a feature, to, yeah, definitely it's a bug. We ran through different tools, like automated and manual tools, to adapt to this environment. And I thought maybe a fun idea I've been having about how to annotate this last remaining quadrant of manual checks that we don't want to linger in our code base. this has been it for me. And fun enough, Wolt is hiring front-end developers. So if you want to work on some weirdo issues like this, we could probably get to do it together if you want. That's it.
Thank you. Maybe somebody has some questions for Fotis that came all the way from Helsinki, by the way. Just for us. No questions? Okay.
I think I saw, yes.
Sure. Question: have you ever found any issues with Chromium-based browsers that are different to Chrome? Is there a bug in the Chromium browser that's not Chrome?
Yeah, I think the biggest one that I saw was the thing I described about ads. And the reason it happens is that, and I think it's a category of issue that will happen again in the future. Chrome specifically has server-side feature flags. They call it fins. So sometimes when there is a bug, they can fix it with a fins flag on the server side. But for example, Edge and Arc and other browsers that are based on Chromium, they do not share that server infrastructure, that Google server infrastructure. So there are categories of issue. I haven't seen a category that shows up only in Edge, but I have seen categories of issue that get fixed in Chromium via such a flag, but Edge only gets it in the next version. So it can happen, and it's pretty frustrating when it does, because then you kind of don't notice it easily, which kind of sucks also. Yeah.
Thank you, Pastor. Can we use bugs for good? Are there any useful bugs?
Ooh. I guess it would be, well, it could be like some kind of bug that allows you to, that sounds like a, okay, so if there was a bug that allows you to do something useful, basically like some capability that the browser would not expose, that could be good, but also it sounds like a security nightmare. So maybe no, but on the other hand, there are quirks that we rely on still, I think, that we don't know they are underspecified, and that's how they just stay there forever. Yeah, I have to think about this a little bit more to see if there's something that jumps out, but I would say that certainly there are bugs that we are relying on, but I don't know if that's a good thing by itself. Yeah.
You mentioned that you report bugs to Chromium. Maybe you have people who can fix them probably, or it's not its scope.
Yeah, so I have thought about this a lot actually. I have managed to compile Chromium on my laptop. Well, I'll talk about Chromium specifically because I haven't contributed to WebKit or to Gecko, to Firefox. Building Chromium locally on your machine without access to Google's server-based builds is a real nightmare. Maybe somebody who's more familiar with C++ than I am, I'm not very familiar with C++, let me tell you, could do it efficiently, but it took like 80 gigabytes of disk space. That's not an exaggeration. I only realized it was still there last week, and the better part of an hour. So we are not yet at the part where we're actively like, let's say, let's hire somebody to work on this, but it's definitely a possibility. For example, there are companies that mostly work with browsers. So Igalia is one, very popular. They're based in Spain, I believe. They're like a co-op. And Beaucoup, I think they're in France, that actually, I bet you could hire them to do some of this work. And in fact, something like the Focus Visible Selector, it was people putting money together for Igalia to make changes to Chromium. Sounds a bit funny, but it's true. So if I really wanted, and like the bake a cake kind of issue that I have considered it. But I mean, it's a pretty high bar, like to get there. On the other hand, what we have done is when we file bugs, we also try, if there is a bug in the specification, to put in tests. So the reason I was so happy about that little quadrant that was red was that because I wrote the tests for it, and then I had to go to the browser vendor and say, look, it's not doing the thing. And I think that gets you pretty far. I think a well-structured report and maybe a platform test is, I think, as close as you can get to fixing the bug without contracting someone or doing it kind of yourself. But yeah.
Thank you.
Colleague?
Oh,
I actually had a pretty similar question related to that. I found that sometimes, like, there are some bugs I filed, 10 years ago, and they never get fixed. Apparently, because nobody else thinks it's very important, right? But do you have an experience, like, are there some bugs that get fixed faster, or do you know anything? Like, what can you do?
yeah, there's definitely like some, I think some recency bias in how bugs get triaged. I think definitely the more convincing the description and the more exact it is and the simpler the reproduction is, I think the more likely it is to get fixed. I think that much is kind of clear. But you're right, sometimes there are, especially feature requests and stuff like that, they're not easy to prioritize. Something like interop is pretty good nowadays. So for example, there are these surveys that you could get people to vote for something. But unfortunately, yeah, there are definitely bugs that do not get prioritized because there's not enough noise about them. Even for example, like the content security policy shortcoming, let's say, of the spec, it was lying around for a couple of months until we managed to like make enough noise to kind of get it to that. And of course, we're a company of a pretty big scale, so it's kind of, maybe that helps to say, hey, there's 1 million users that could be getting better security, but no, to be honest, the best I think you can do is have a small enough reproduction and a nice description, but sometimes it is a roulette, unfortunately. Yeah.